So in my last video, video number 1 of this 386DX series, I showed this graphic of what I was kind of thinking about for a PCB layout for some type of a prototype board that I could start experimenting, with the 386 processor, the DX specifically. I have actually completed what I'm going to order today for the real version, first version of this prototype board. And let me show you what that looks like. So this is the fully routed, ready to order board that I think I'm going to go with. And you can see I've added quite a bit of stuff to it from the last one, and a couple of reasons for that. As I was getting into this, it was large enough already that the cost was noticeable when I ordered it. And so I'm trying to minimize how many times I need to order these larger PCBs. Just because shipping is expensive and the PCBs for this size are fairly expensive too, especially if I go with more than 2-layer. So I did end up adding some stuff to this from the previous version, and I thought I'd just walk through what are some of the major components or my thinking and my approach for this prototype board. The first requirement that I'm going with is I want to keep to a 2-layer board. And that maybe makes it a little bit more difficult trying to compact this all physically. But the reason I want to stick with a 2-layer is so that all the traces are accessible either on the top or on the bottom. I imagine as I go through this, I'm going to find cases where my initial schematic is not correct, or some stuff that I know is not finished in this board that I'll have to finish later. And if I can at least do trace cuts and bodge wires, I can continue to use this board and make it fit my needs as I go forward. However, if I go with 4-layer and I have those traces maybe running in the inside layers, that could be a little bit more difficult for me. Not impossible, but more difficult, I think, in general. I'm also minimizing any surface mount here, really for that same reason. I like the through hole, easy to manipulate and pull out pins and do things like that as I go. So that's what this version looks like. Maybe as I get into this, I could start with some of the basics up here in the upper left. I'm just bringing in a few different connections for power. So I have a standard DC barrel connector here. And then I also have a screw terminal type of connector right here, and I can bring power in on either of those. I could also use just a pin header for the power. I have those pin headers all over this board, but I likely will not do that. So I think this DC barrel connector is probably what I'll use. If you've watched my other more recent videos, my preference is banana jacks, but for this board, I'm just going to start out with a DC barrel connector. It's lower cost and will work fine, and I'm going to save my banana connectors for the next version of this when it's maybe closer to something that I've cleaned up a bit. And I've got simple things like this DS1232, which is kind of a delayed reset. It holds the reset line when I turn the system on so that the processor basically give it a little bit of time before it comes out of reset, just to let, I think, voltages stabilize. Whatever other initialization, this has a certain number of cycles that it's got to get through too before I want to come out of that reset. So I'm using the DS1232 for that. And then tied to that is the button up here, which is a reset. So that will control the reset coming into the circuit, but then I'll have this P-sock down here will actually then do the conversion of that into the reset that'll get used for the entire, all the ICs that you see on the board. I do have a PS2 connector for a keyboard, a PS2 connector for a mouse, and I also have a USB connector for a mouse. Now the mouse is used in PS2 mode though, so even though it's physically a USB connector, it's going to use it as a PS2 type of mouse. So that's what these 3 connectors are. As far as the core of the system, once I've got power coming into it, I have the processor itself. So here's my 386DX. Probably more capacitors around it than I need, but that is what I have. Then I come down here with the 387. I decided to put in the math coprocessor in this build. And I think I have it mostly wired up right in the schematic. but I at least wanted to get it on here. It doesn't take up a lot of space. It does complicate the routing because there's a lot to then be routed into that 386 and 387 and connect all of that. But I figured I'd at least put it on, and if it ends up it doesn't work out, that's fine. But if I can get it going on this board, that would be great. I have all my address latches, I have all my data transceivers, and this is kind of how I arrange them. Really, out of this 386, most of that addressing is coming from this upper portion of the chip, so that works well going that way. Data transceivers, maybe not quite as clean, but as far as how they come out of this layout here, but that seems to be looking okay. I do have my control latch over here, and I added another spot for an empty. This is an empty control latch. It has power and the enable signals going to it, but nothing actually being latched. Because I think as I work on the system, I'm going to need more latches, and this one is full up here, this U5. Now, as far as the decode logic, I did put in 2 of the PALs. If you go back to the 386DX documentation, or at least the hardware design guide, I'm seeing that really Intel is suggesting you've got this pair of PALs that can get used. And I talked about that a little bit in my last video. So I put in the PALs, and my intention is to use those as the code is provided in that design guide. So pretty much as any standard Intel 386 would use these, that's what these should be when I get them working. That did allow me to trim out one of my PSOCs. So I have one PSOC that I'm going to use up here that's going to do all of my decode logic on the board, or a lot of it, I should say. So for the enables, for the flash, for the RAM, for the math coprocessor, for this VIA up here, any of that type of stuff, I'm going to handle in this decode chip. And right now I'm bringing a lot of addressing into it that I probably don't need all of it, and later I'll trim that down as I understand which addresses I'm really going to be using. And then I have another PSOC down here that's going to do my clock and reset generation. And I don't even have a crystal or an oscillator on this board. So my intention is to use what's built into the PSOC for generating that clock signal. So I have a few different clock signals I need to generate coming out of this. There's the main clock, there's a clock 2. I'm also going to have a separate clock that I run to the VIA, just so I can control timing a little bit. I also have an A0, A1 generator, because there is no A0, A1 on this setup. You have to actually generate those signals. And same with the S0, S1. So I'll have to generate those signals. So this PSOC is just going to be used as really the clock reset generator, because I cannot source those ICs. And then also as these generators for A0, A1, S0, S1. Now, one thing to note on these PSOCs, I'm not doing any coding on these PSOCs. I'm just using them as simple ways to essentially do a PLD. And the reason I'm using these is just because the user interface to design on them and update them is the best I've seen. So I really like the interface. I can get in, I can graphically lay out my logic, and then I can just upload it basically through the USB port on these. Now, once I understand what this is ultimately going to look like, maybe I will turn that back into discrete 7400 series ICs or something like that. But we'll see. I like these because they give me a lot of flexibility to change things around. And on my 286 build, that's come in handy. As I've added more devices, more I/O, I can change the addressing of all that stuff around pretty easily. Now, over here, you'll also see that there's a little nano, and that nano takes in the PS2 signals for the keyboard and mouse and essentially converts it to SPI so that my 386 can access and use all of that mouse and keyboard data through SPI code that I'd be running. And SPI code, I do all of that through this 65C22 up here, this VIA versatile interface adapter. And this is all the same as it is on my 286 build, so nothing too different there. But the idea is a 386 can leverage the 6522 for SPI functionality, and then it's going through this nano for all the keyboard mouse data. I offload some of that processing and simplify the data that is retrieved. And that's been working out well in my 286 build, so I'm going to continue to use that approach. You'll also see I've scattered some ICs around the board that have no label, and that is because all they are is basically an empty 14-pin or 16-pin IC that has power and ground applied to it along with a capacitor and then a header. So I can plug in whatever I want for ICs in these later if I decide I need an AND gate or a NAND gate or whatever type of gates I might need that would help me instead of having it run through the PSOCs. Or as an example right now, all the clock that comes out of here is going to just simply connect. For example, my main clock signal will go to everything that needs a clock signal. I'm not doing any type of buffer or fan out on the clock. But later I can easily add that. I can just drop in. I have some 14-pin clock fan out buffer chips that I could put one in here, and I could just bring that signal over and then just reroute from there to all of the individual clock signals throughout the board. For example, I might run an independent clock signal to each of the ISA slots. That's what I'm doing on the 286, and that has worked out well. But for now, for simplicity, I've just said I'm not going to do that. I'm going to stick with a single clock, see how well it works. But I have room to drop in other ICs. So I have some of those right here, and these three, and then I have this, like I mentioned, this extra latch over here. And if you look in the upper right of the board, I have some more of these sitting up here that I can use. Really just either 7-pin or, 14-pin or 16-pin ICs. I do also have headers on here, so I can get to all of the address pins, I can get to all of the data pins, I can get to all the control pins. And then I also put in this header called empty. Basically, if I have any other signals I want to be able to quickly attach, let's say a debug cable to, I can bring those signals into half of this header and then connect to my other half of the header with, let's say, an Arduino or an actual logic analyzer of some sort. So I think I'll have pretty easy access if I want to get an Arduino debugger running and run this at a slower speed. You know, that on my 286, I started with a breadboard and obviously started with much slower speeds, and that debugger really helped me understand how to connect all this stuff, how to make it work. So I want to make sure I have that easy access if I decide that I need to get into debugging at that level on this. I did put in a priority interrupt controller just for a couple of the basic interrupts, and I'll switch over to the schematic in a second and maybe walk through that schematic. I have a pair of flash chips, basically for my ROM, and then I have my 4 RAM chips. And you will see a little jumper here. The default that I'm going to set these up with for my decode logic is that the chip selects will all be grounded, but I'm doing that through a jumper so that if later I want to change that logic, I just pull the jumper and run something else for the chip select. And then I did put in 3 ISA slots, spread out a little bit further than the traditional ISA slot distance would be, just to fit. I measured my widest card, so when I plug it in, the most it would stick out. And I have room for 3, so I could probably run my video card, I could run my IDE interface card, and then either the extended memory card that I've recently got the PCB in for, or sound card or something else that I can plug into this. And then I do have some pull up or pull down resistors here just for my address and data lines if I want to use those. And on previous builds, pulling up my address and data lines at the end of this has been helpful. And I somewhat arbitrarily put in, some of these mounting connectors that are grounded throughout the board. I don't know if I'll put this in on any type of a substrate and actually use any of the mounts, but they're there in case I do. And of course, I try to put those where I'm going to be physically pressing on the board a lot. So this would be the first candidate, is around these flash chips. Those will be in ZIF sockets. So some support here for those. And I'm just scanning to see, I also have a nano up here that is taking SPI data from the processor and then submitting commands and data then over to my PC. So I can submit a command to this to write out serial data to the PC. So that's going to be my main debug output as I'm working on this. And I won't start with video like a VGA output. I'm going to try to just get everything, the core processor running and outputting to serial to my PC. That's my step number one. So that's what this Nano is for up here. Also, that Nano has I2C control support, and you'll see there's a small 4-pin header here. That'll go to an I2C OLED screen, similar to the one I've used on my 286 build. So that might show me post information or other debugging information as I'm getting into getting this system up and running. And just looking to see if I have anything else. I have miscellaneous headers for power and ground around the board. Really, that's to help me mostly plug in my scope ground to an easy ground connection. But I'm not seeing much else that I haven't talked about. So I think that's the gist of it. If I go back to the actual routing of this, there's a lot there. So, if I take a look, I can maybe hide the bottom layer. So that's the top as far as all of the routing, and there's the bottom as far as the routing, all the blue that you see. So pretty busy in all of this, and I try to spend some time to get this to be good enough or adequate for this board. This isn't great. I did not manually route this entire board, nor would I probably choose to do so. So I did use an auto router to help me with this just for the sake of time, and it seemed to do an okay job. So I'm gonna use what I've got here. And maybe as far as design rules, the only thing I really changed is the power. I did increase that slightly as far as track width, slightly increase the via diameter and the drill diameter. But everything else is running this kind of standard 0.254 millimeters for everything else. I guess that's not VCC or ground. And again, this is just a 2-layer, so I just have a top and a bottom. There is no inner layer for signal or anything else. I did put in a copper fill though, and so there's a top. It's not going to show up well here, but there's a top copper fill and a bottom copper fill. I have one set to ground and one set to VCC. So you'll see that when I'm in the 3D view, you can tell this is all filled in. So I should have pretty good power distribution around the board because there is a lot of copper fill. And same with the back. When I get to that, there's a lot of copper to help get all that power distributed a bit better than just those traces. So I'm hoping between the copper fill and any capacitance I put around here, I should be okay. If I go back to the actual schematic itself for a minute, I've just got some real quick stuff around that DS1232, and I gave myself some options so I could pull some pins and run an external clock to the board and bring that in on a pin. Same with an external reset, things like that. If I get into the processor itself, that's this schematic icon that you see here, and I've done my best to kind of read through the documentation and set these up the way I think I'm going to need them, but there's definitely some possibility that I don't have some of this right, and then I'll have to come back and adjust if that's the case. And same with the math coprocessor. On this, there were a few pins. I wasn't exactly sure how I'm going to use them yet, so I just brought them out to a header, and I'll deal with that later. And then I get down to my ROM and my RAM. And as I was looking at the design guide, it seems like for the ROM, this would be the same approach as it was on my 286. I would run address 1 into the address 0 pin, 2 into 1, etc., all the way up. And so that's what I've done there. And then the RAM is a bit different than my 286. That off by 1 on the address line, it's actually by 2. So I have 4 RAM chips here. So the highest byte, byte 3, byte 2, byte 1, byte 0. But then on the addressing, the way I understand it is I would actually shift it by 2. So I have the bus address line 20 going into address 18 of that flash memory chip. And the way I'm setting it up right now is all the chip enables, I'm going to pull to ground. So they'll all be chip enabled all the time. And then the output enable, Either I'll output all 4 at once or none, or I will write to one or more of these with the write enable signal, and I have a unique signal for each chip. So I have RAM 3, RAM 2, RAM 1, and RAM 0 write enable. And that'll, of course, be coming from my PSOC that's going to control those enable signals. I have my interrupt controller over here to the right. Again, nothing too different there other than I did shift this. It seems like in the design guides, they're running the A0 off of the bus A2 signal, so that's what I've got going on there. Maybe on the math coprocessor, let's see, was there anything for addressing? There wasn't much for address signals other than the reference documentation showed A2 being used for this CMD0, so that's what I used at this point. So I have the interrupt controller, I just have an inverter sitting down here, I have all of these just generic ICs as all these are being used, so even if they show up as some specific thing, I'm really just using them as the placeholder for future things. I have my nanos, I have this W65C22, again that's doing all my SPI, and then I have a bunch of SPI headers so that when I'm over here I can plug in other SPI devices that I can use. As I go up in this, I then have the Nano with the keyboard mouse, and so that really is this support. I am using a flip-flop. George Foote had a nice little schematic to do an auto reset on the keyboard, and for my keyboard that is needed. I think I could handle it through the Nano, but this is such a simple solution that when I turn on the system, it takes my USB keyboard, which I think is being treated as a PS2 keyboard, and then resets it, and that auto reset is a great little circuit. So thanks to George for that. And then I've just got a bunch of headers that I'm using, and then I have all of my data transceivers, address latches, control latches sitting down here. And for these, I know one thing I probably am going to have to change, and I'll work with this later with a cut trace. But when I get into the data transceivers, documentation all shows I should be able to use this DEN signal. But I know on my 286, I actually had to put in a little extra logic so that when my math coprocessor was enabled, I would not enable the data transceivers, because the math coprocessor, if I look at it, it's using the data lines directly to the processor, and it's not using the data lines that would come out of a data transceiver. It's not the external bus, it's the internal bus data lines I'm using on my math coprocessor. So I might need to tweak this signal here when I get to actually trying to fire up the math coprocessor, if I get to that stage on this board. But control latches, this is that blank one I was talking about, my address latching, pretty basic stuff there. And then I have these PSOCs up here, so 2 of them. On the previous board I was showing 3, but I was able to cut those down because I put in the PALs. And so then you can kind of see the types of signals that I'm going to use on these. So one of the PSOCs is going to bring in really address line 1 and pretty much all the way up here to 23, and then also 31. Those are the ones I think I need at least to get going here. And later that might change. I might pull some of these that I don't need to use. I don't know yet what that's going to look like. And then all these other signals that I'm either generating from this other PSOC or are coming out of the processor or wherever they may be coming from. And then generating a lot of these signals too. So you can kind of see how I have all of this configured. And by the time I think I get things up and running, of course, that's going to change. So this is just what I understand going through the documentation. I'm probably going to need for ins and outs for signals. And little by little, I'll try to get those all connected up and working. I do have a miscellaneous sheet here that is just capacitors and these standoffs and power connector, power LEDs, whatever it might be. And then I do have the 2 PAL chips. So let me change this to black on white. But I do have a pair of these GAL 16V8s. And these are marked with 15 LPs, but I'm actually going to be using likely 7s So I have some 7s that I'll use. I also have some 10s, but I think I'll start with the 7s. But we'll see what happens there. But these signals should match up with the code that Intel provides to put onto these PALs. There's some of the pins that I don't think I'm going to need or plan to use, and so those I've just simply not connected here. But later, if I want to, of course, I could solder to the bottom to that pin, and these will go into a socket, so I can solder on the bottom side into that socket pin if I want to tap into these other signals. But I can see all my inputs, I can see my expected outputs, and I'm going to use all of those that you see here. So hopefully I can get those coded and programmed the way that Intel provides the code for. And then I have on this ISA, I have my 3 ISA slots. And I think for the most part, I'm using most of the signals as you would expect there. I'm not sending negative 5 volt or any of the 12 volt. That's just stuff I'm not going to use. There are some things like refresh, and some of this gets into DRAM, dynamic RAM, I believe, or DRAM. So I don't think I'm going to be using that. There might be a couple other signals that I don't know necessarily if I'll be using. I'm not doing any DMA at this point, but if you see a signal here, I am sending the signal. That doesn't mean I'm necessarily using it on the other side. And all of these signals really are pretty compatible with what I've got on my 286. So I don't think there's any big changes here. So what I should see is I should be able to take a card out of my 286 build, put it into the 386DX build, and hope that would all work fine. Maybe with some address decode changes or IO address changes for some of my cards, but in general, the same cards should work with the same signals coming through. And then these are just those pull-ups that I have at the end of the bus at the very end. So I think that is pretty much a walkthrough. And this is what I'm going to start working with. And I'm going to go ahead and get this ordered up. This is an expensive board. And so when I go in to order it, I first did a 4-layer board, and it was double the price. So that... I was curious what it would come up as, and it was too expensive. So this is still expensive though. So when I pull this up, I'll have it double check, make sure DRC still looks good on it. But I think this is coming up at like $75 US for 5 of these boards. So $15 a board, or in this case, $70 for 5 of them. So that is getting a little expensive. What is that? Whatever it ends up being, $14 a board or something. And then by the time I add shipping to that, that's going to be another $20. So I'll be into these $20 a board, and realistically, I'll probably only use 1 or 2 of them. So this is a $100 that I'm going to have to spend to kind of get this moving forward. So hopefully I'll get some good use out of this. And that cost is just because it is so large. You can see here I've got it marked 440 millimeters by 217 millimeters. So it's a good size board, which pros and cons to that. But normally I don't like boards this big unless it's kind of a final type of system board. But I think this is going to let me do a bunch of experimenting along the way. Let me modify traces and run bodge wire as I need to. The thing for me that I have to be most careful of is, do I have the right data and address lines running to things like ROM and RAM? Because if I was off on that and say I didn't shift it the proper number of lines or whatever, then all of a sudden I have hundreds of cuts to make, or minimally dozens of cuts to make and bodge wires, and that's what I don't want to be doing. But to modify different control signals and things like that, that's pretty minor bodge wire work if I need to do that type of thing. In a lot of cases, I can control changes through the PSOCs, so that will be handy. But that's how I'm approaching this, and I think when I get the board in, which will probably be a month away, I will start with just the processor and the latches, and I'll have to have the PALs running. I'll have to have my decode running up here. but I won't worry about mouse keyboard. I'm not going to worry about the math coprocessor or the VIA or the PIC. And let's see, did I even show the PIC in here? Let me go back up to this. Yeah, I did show the interrupt controller down here. So I do have that interrupt controller that will get used. And the reason I put it in here for now, at least, is for the keyboard, and maybe a timer if I get to that, but keyboard for sure. And if you've been following the 286 series, I'm using that VIA for my timer, so I might use 2 of these interrupts on this board. Maybe these other 2 if I get to a mouse or sound card on this board, which I don't think I'll get that far with this board. I will use the debug up here right away because that's how I'm going to output and see if things are actually working. So I need to get SPI working from the 386 to that right away, so I have some type of a debug output. And I'll of course need to have my flash and my RAM in. I won't be using the ISA slots to start. So that's what I'll start working through. Maybe a month from now, I'll start with the core and just slowly build out, and I'll post as I go. What am I learning? How much did I get right on this initial schematic, and how much is completely wrong? The nice thing is, from my 286 to this, so many concepts come across and are identical or very, very similar. And a lot of the work I'll be doing on the 286, like an add-in card for memory, that same memory card, I think, should be able to plug in here and get leveraged by this system. Maybe a different addressing or something I would do with it, but again, physically, those things should be able to go back and forth. So that's it for this. I'm going to switch back over to the 286 series here, probably for the next few weeks at least, 3 to 4 weeks, and just focus exclusively on that. And I have plenty of work to do there, so if you're following that series, keep an eye out for some other updates there. Thanks for watching, and as always, feedback is welcome. If you're seeing things that you already know are going to cause me a lot of pain, throw a note in the YouTube comments, and that way I can at least start preparing for how I'll improve this as I go.